All right, let's take a look at these application problems. All right. A laser is placed on the ground 20 feet from the base of a tree. When the laser is tilted at an angle of 75 degrees, the laser hits the top of the tree. What is the height of the tree? So here's my pathetic looking tree. So here on the ground is my laser. I'm going to make it out a little bit further. Is my laser, and my laser is hits the top of the tree. So here's my laser, and it's 20 feet from the base of the tree. And it's tilted at an angle of 75 degrees. So the height of the tree, what's the height of the tree? So the information here, the h and the 20 are the opposite leg of the adjacent. So we'll use the tangent and set it up that the tangent of 75 is equal to h divided by 20. If we multiply both sides of the equation by 20, then we'll have the height. And if we go to the calculator, we've got the calculator set on degrees to the nearest tenth. And if we have 20 times the tangent of 75, then the tree is 74.6 feet tall. All right. We've got a pilot is flying his plane at an altitude of 20,000 feet. He looks out the window. He notices a runway at an angle of depression of 15 degrees. What's the horizontal distance from the plane to the runway? Okay, so here's our ground. Here is our plane. It's a sad looking plane. And here's our pilot in the plane. And here's the pilot's line of sight. And at an angle of depression, the pilot looks down, tilts his head 15 degrees, and sees the runway. This is the start of the runway. Now remember the height of the plane is 20,000 feet, that it's 20,000 feet above the ground. It doesn't want the hypotenuse. That's not horizontal. It wants the horizontal distance from the plane here, from this nose of the plane to the runway. All right, so I kind of drew this a little bit big. Let's shrink this up a little bit. I wish I had time to add to my drawing here. Here we have the two legs. Now, this angle right now is outside of my triangle. I need it to be, but the pilot's line of sight and the ground we're assuming are parallel, and two parallel lines cut by a transversal, alternate interior angles are congruent. So this angle is 15, or somebody might sit there and say that they want to 75 degrees and 15 degrees are complementary. So you could work with this 75 degrees. Let's do that just to be different. We've got the tangent of 75 degrees being the opposite leg over the adjacent leg. So we've got that D is equal to, if we multiply both sides by 20,000, and if we go to the calculator, if we take 20,000, one thing I don't like about these calculators, it doesn't give the comma in there. Some of the older calculators, the Hewlett-Packard calculators, maybe, or I would bet you financial calculators on TIs would probably do it, but it makes the commas for the thousands period kind of makes it a little bit easier to read. It's awful easy to accidentally not have enough zeros or to have too many zeros. Or at least it is for me. So how far is he from the runway? 74,641 feet from so quite a distance from the runway. But he's only tilting his head just a little bit. If he had to tilt his head a lot, you know, some 60, 80 degrees, he's right over the top of it and stuff. So even though he's far away, he needs to start his descent kind of slowly. All right, so I hope that helps. Let's take a look at this one. We have a set of stairs that has a vertical rise of 10 feet and a horizontal distance of 15 feet. At what angle should the railing be installed to match the slope of the stairs? All right, so let's draw a picture. So here is my ground or floor, and if we know that steps are like this, but I'm just going to draw my right triangle like that. Okay. And I can make this a little bit bigger. All right. That's a bad looking staircase, isn't it? All right, so it has a vertical rise. Vertical is up and down 10 feet, and a horizontal distance of 15 feet. And it wants this angle theta because we're assuming that if we build our handrail to help people go up the steps, that the handrail is also at an angle of theta. It's parallel to this line on my triangle. All right. So we've got the opposite leg and the adjacent leg, so that's the tangent. The tangent, if we call the angle theta, I guess you could call it A or B or whatever you want. I'm used to using theta. Since I'm going to give the calculator the ratio and I want the angle, I have to use the inverse tangent. And I believe my calculator is still set to degrees to the nearest tenth. And we've got that the inverse tangent of 10 divided by 15 is 33.7 degrees. So that's the angle at which you should attach your handrail. All right, so hey, I hope that helps.